So in this video, we'll continue our discussion on the topic of trigonometric substitutions. And now, please look at this page again. Whenever the integral contains a square root term, where the expression inside the square root is something like a squared minus x squared, where a is constant, or a squared plus x squared, or x squared minus a squared. You can feel free to use the hint that I give you on the right-hand side for each expression. And let's do an example now. So please look at the current problem. Now the integral has something that we want to talk about, which is the square root of x squared plus 4 at the bottom of the fraction. And you can think of this as square root of x squared plus a squared. So it means a squared now is 4, and it means that the a as a constant is actually 2. And based on my previous hint, I think you can try to use a trigonometric substitution where x is actually 2 times tangent theta. And naturally, the second step is that we have to write down the dx, which is the derivative of 2 times tangent theta d theta. So the derivative of 2 times tangent theta is actually 2 times secant square theta. And with this, we'll try to convert the whole integral to the variable theta. And let's do it together. So the dx is 2 times secant square theta d theta, which is the dx term. And let's look at the bottom of the fraction. So x squared is clear because x squared is the same as 2 times tangent theta square. And let's look at the remaining term, which is about the square root. And that's the key here. We use the substitution x equals 2 times tangent theta because by using that, we can actually simplify this expression by taking out the square roots. Let's see how we can do that. So I replace x by 2 times tangent theta inside the square root. And please expand it carefully on your own. You're getting 4 times tangent square theta plus 4 inside the square root, and 4 as a common factor can be taken out. So inside the bracket, you actually have 1 plus tangent square theta, right? And I hope you notice something which is familiar to you, because 1 plus tangent square theta is a famous trigonometric identity where it is actually the same as secant square theta, right? And now, please take a look. You are taking the square root of 4 times secant square theta. So it means that this expression is actually the same as 2 secant theta, right? Now you see, which means that the square root is out after doing all these algebraic manipulations successfully to convert the variable x back to the variable theta. So I replace it in terms of the 2 secant theta inside the purple star on the left-hand side. Now, it's up to you to do the cancellation. First, there's only one copy of 2 at the top of the fractions, but you actually have 3 copies of 2, right, in the bottom. So it means that I can take out the constant, which is 1 over 4. 4 means 2 square, of course. And inside the integral, we have all these trigonometric functions. But of course, we can also cancel out one copy of the secant theta, right? So it means that now what we have inside the integral is a secant theta divided by tangent square theta d theta. Now, this integral may not be that easy to do, but we have to kind of try our luck. You see now there's no way to easily do this integration in one step because we don't have any formula in our mind, but we have to try to do some maybe cancellation ourselves. Secant theta is the same as 1 over cosine theta, and tangent square theta is the same as sine square theta divided by cosine square theta, right? And you see, we can invert the fraction in the bottom, but anyway, after the inversion, I think one copy of cosine theta is cancelled. And it means that we are left with the following, which is the fraction cosine theta divided by sine square theta. So let's put it back to the left-hand side, which means you are actually integrating cosine theta divided by square theta, right? And can you see how to do that? Now you see maybe a good substitution can work it out if you observe something. For example, we can use a second substitution in this problem. So let's say if I use a du to take out one copy of cosine, which is at the top. So why am I doing that? But we have to try it out. The correct u should be the integration of cosine theta, which is sine theta. So essentially, I'm suggesting that you can convert the variable theta to, and let's see whether it works or not. And let's go to the left-hand side, because now you see the bottom is actually u square, right? So we have something divided by u squared. And the top is clear because the top, which is cosine theta, the theta is exactly the right-hand side of the second line here, which means the top is actually du. And I trust that you are able to do this integration because we can simply use a power rule if we express the inside in terms of u power minus 2. So after the power rule, we can write it like this. And please note that it is essentially the same as minus 1 over u inside the bracket, and u was actually sine theta, right? So it means the answer looks something like minus 1 over 4 times sine theta plus constant c. But the final step to this problem, please recall that originally my problem was stated in terms of variable x, and you really have to convert the answer back to the variable x, right? And please recall my substitution in the beginning, which is x equals 2 times tangent theta, right? And we can use a triangle method to help us out. So let's write the right angle triangle together with the angle here, the theta. And tangent theta is the same as x over 2, which means x is the vertical length and 2 is the base length, right? And by the Pythagoras theorem, the longest length, which we call it hypotenuse, is actually square root of 2 squared plus x squared, which is 4 plus x squared. So I think we have enough information. And because my expression in the left-hand side, I want something like 1 over sine theta. So I think 1 over sine theta is what? Sine theta is actually x divided by square root of 4 plus x squared. Of course, we can invert the fraction now to make it square root of 4 plus x squared at the top divided by x, right? And now, which is essentially our final answer, because the final answer, I keep the constant minus 1 over 4 in front, and inside here, it's actually the same as 1 over sine theta, which is square root of 4 plus x squared divided by x, the constant c. And that's the end to this problem.